Right, here we've got a line, L1, that passes through the point 9 minus 4 and has gradient 1/3. Find an equation in this format. A, B, and C are integers. Well, if you remember from my last question, I reckon that this is my favoured way of remembering the equation of a line. It's also nice and easy to remember because you've got y minus y1 equals the gradient m times x minus x1. Remember, x1, y1 is a point on the line. You always need a point and a gradient, and you can always work out gradient if given 2 points. M is the gradient. So these are the key things to remember when using this. So the gradient m is that bit, and we know that x1, y1 is a point on the line. In this case, we have got the point 9 minus 4 as our point on the line here. So I'm going to substitute those in. So I will, and my gradient is minus a third. No, it's not minus a third, it is a third. So I'm going to, my gradient equals a third. Put those all into the right places and we'll get the right answer. So we get y minus y1, which is minus 4, equals m, the third, times x minus x1, and x1 is 9. So take that away from x. Now remember, we want to get these as integers, so we want whole numbers. So let's get rid of this third by timesing throughout by 3. 3 times y gives 3y. Minus 4 is plus 4. Times that by 3 gives us plus 12. And then we're just left with 1 here to times out x minus 9, so you just get x minus 9. Now I'm going to write it all out on the right hand side. So I'm going to get x, because I want to keep x positive, I like doing that, minus 3y. Take away 12 from both sides. 12 away from 9 will give you, what's that going to be, minus 21. And I better write it how they've got it. So we've got x minus 3y minus 21 equals 0. And if you really want to write out what a is obviously going to be the number of x's, which is 1. B is going to be equal to minus 3, so how many lots of y, and C is equal to minus 21, although the question doesn't really ask us for that. Now line L2 passes through the origin O and has gradient minus 2. The lines into L1 and L2 intersect the point P. Calculate the coordinates of P. Well, let's do that bit first. So first of all, we need to find the equation of L2. So pass through the origin and has gradient minus 2. Well, that makes life very easy. Because remember, y equals mx plus c. That's the gradient, again. And this is where it crosses the y-axis. So in our equation, we're told it goes through the origin, so this is going to be 0. It crosses the y-axis at 0. So y will equal minus 2x. What we have, therefore, are two simultaneous equations to be solved. We have this one, equation here, and we're going to combine it with this equation here. Alright? And we're going to solve these simultaneous equations to find out where they cross. And probably the best way to do is just to take this value and put it in. So we know that y is minus 2x, so where there's a y, alright, y is here. We've got a y here, and we know that y is equal to minus 2x in this case. So let's put that all the way in there. Okay? So put that in there, and we'll get our help us to eliminate y's and then just have an equation in x, and then once we've got x's we can find the y's. So let's do that. So put the minus 2x in that, we'll get x. So this implies that x equals minus 3 times by, put it all in brackets, minus 2x. Good habit to get in putting in brackets, because then you will be less likely to make a mistake with the signs. Minus the 21 equals 0. Let's simplify all of that. So we get x, we've got minus 3 times minus 2 gives us plus 6x, so that's 7x. Minus 21 equals 0, so 7x, add 21 to both sides is 21, x will equal 3 dividing throughout by 7. Divide that by 7, get x. Divide that by 7, you get 3. Let's put this back into y equals minus 2x to find the y value. So therefore y will equal minus 2 times that, which is minus 6. Okay, calculate the coordinates of P, sorry, I've done that. Given L1 crosses the y-axis at point C1, or point C even, this is a comma, I thought the 1. Calculate the exact area OCP. Well, let's just go back to, this is the equation here. We know that it crosses the y-axis at point C, so we can rearrange this back into y equals mx plus c format. We can find out where it crosses C. Let's rearrange this in y equals mx plus c format. Well, for starters, let's get, I'm going to take from here. We get the 3y on the other side, so we get x. If I take this out to here, I'm going to take x and I'm going to make it minus 21 equals 3y. And divide throughout by 3, so I get a third of x minus 7 equals y. So we can see this crosses the y-axis at minus 7. So we've got one crossing at 0. We've got these intersecting at 3 minus 6. So let's draw a sketch of what's going on. So we've got one line crossing at 0. We know that they're crossing at 3 minus 6. So there's 3, there's minus 6. And then we've got another one crossing at minus 7. So we can now find the area of this triangle. This distance is 7 and this distance is 3. So therefore the area will equal a half base. Half the base is half times 7 times the perpendicular height. We know this is perpendicular to the base because this is a y-axis and this is an x-axis. So times by 3. And that will give us 21 times by half, which is 10.5 units squared.